Our objective today is I will be able to write and evaluate numerical expressions in exponential form using product, quotient, power, power of a product, power of a quotient, zero product property, and negative exponent rules. So that is a lot of rules there, but we have learned all of them except for zero product property and negative exponents. So we're just adding 2 more today. Please make sure you have your yellow paper out and you are taking notes on your yellow paper because you will use your yellow paper next week for review of exponent rules. All right, so I'm going to solve the following. Okay, so you should have realized this is a quotient rule and that you are going to keep the base, which is 5, and subtract the exponents. So 6 minus 6 is 0. So we get 5 to the 0. Okay. Zero product property, though, has a rule for zero exponents. Right? So if I think about 3 divided by 3 and 100 divided by 100, what do those mean? What do those equal? Well, 3 divided by 3 is 1. 100 divided by 100 is 1. Right? Anything divided by itself is always 1. So therefore, if I'm going to 5 to the 6 divided by 5 to the 6, that's the same thing. So I can think of 5 to the 6 over 5 to the 6 as equaling 1. Okay, so 5 to the 0 power equals 1. So if I have 1,000, all right, so if I'm looking at 10 million, I think that's what that number is, 10 million to the 0 power, that's going to be 1. Okay, so anything to the 0 power is 1. So in our own words, we're literally going to just write that. Anything to the 0 power equals 1. All right, so if we look at this first example, 4 to the 0 is going to be just 1. Okay, this one's a little bit different. If I'm looking at this, you got to think, where is the exponent? Is it on the 9 or the 3? And the exponent is only on the number that it's literally on, unless there are parentheses around everything. So 9 times 3 to the 0 is like saying 9 times 1, which is just 9. If this was instead 9 times 3 in parentheses to the 0, then the whole thing would be 1. But because just the 3 is to the 0, the 3 is the only thing that becomes 1. All right, I'm going to give you a couple seconds. I want you to pause the video, and I want you to solve these 2 problems. Okay, so you should have paused the video, and you should have gotten that giant number, which I don't actually even know what it is 1. And this problem here is just 1 because the whole thing is to the 0 power. So if you spent time trying to solve that one, you did way too much work. So anything to the 0 power is 1 always. All right, next we have 5 to the 6 over 5 to the 9. If I solve that, I'm going to get 5 to the negative 3 if you use your integer rules right, because 6 minus 9, you add the opposite, and you different signs subtract, keep sign a large number, so you get negative 3. So there is a rule that you cannot have negative exponents. So I've said for right now you are okay with it, but you are not allowed to have negative exponents. So when you have a negative exponent, they actually flip the where the exponent goes. So 5 to the negative 3, you're going to rewrite that as 1 over 5 cubed where this 3 is now positive. So like if you think of 5 to the negative 3 over 1, I've technically just flipped that fraction and made the negative positive. Okay, this one is the same way. I'm going to flip that fraction, and it's going to become 4 squared over 1, where the exponent is now positive. I don't have a great way to write that in our own words for right now, so we're just going to do a few more examples, and maybe you can come up with something on your own. So my thinking, if I see 4 to the negative 7, I know I'm not allowed to have a negative, so I'm going to rewrite it as 1 over 4 to the positive 7. Okay. This one, again, I see a negative. I cannot have a negative, so I'm going to flip where the negative goes. So I don't actually flip the whole fraction in this case. I only flip where the negative is. So the 5 stays on the top because the 5 is not negative, so I don't need to change that. And I multiply that by 6 squared because the 6 becomes positive. I need to move it up to the top of the fraction in order for it to become positive. All right, so if I'm solving this one, the first thing I'm going to do is keep the base, subtract the exponents. So I get 6. 3 minus 5 is negative 2. Times 4. 4 minus 1 is 3. Okay, I can't have this negative, so I'm going to make a fraction and write 4 cubed over 6 to the positive 2. Okay, if you understand that, great. If not, another way to understand it is by thinking, if I look just at this part, 6 cubed over 6 to the 5th. Okay, I ask myself, where is the biggest exponent? So here's the biggest exponent. The biggest exponent is on the bottom. So that means my answer should end up on the bottom. So I'm going to, if I think of it that way, I can take my biggest number minus my smaller number. So 5 minus 3 is 2. And my answer is going to end up on the bottom because the biggest exponent's on the bottom. So I actually get 6 squared on the bottom of my fraction and 4 cubed still on the top because my biggest exponent is on the top. Okay, so if I'm looking at this one, I'm going to use that method. So if I look at 10 to the 10 and 10 cubed, the biggest exponent is 10. So I know my answer is going to be on the top of my fraction. So 10 minus 3 is 7, so I get 10 to the 7th. Then if I look at my 8s, all right, my biggest exponent is on the bottom of my fraction, so 8 is going to end up on the bottom. And 8 minus 2 is 6, so it's going to be 8 to the 6th. And then finally, if I look at 7 to the 4 and 7 to the negative 3, again, that's going to end up on the top of my fraction because 4 is bigger than negative 3. So I subtract. 4 minus negative 3 is 7. So I get 7 to the 7th power. All right, that is the end of the video. Work on your worksheet from yesterday. If you have any questions, you can email me. I am in the building. I just am not in class. Good luck.